Hi, and welcome to Lesson 5.5b, where we will be looking at standard form. There's two goals for this lesson. The very first goal is I can find and graph the x and y intercepts from an equation that is written in standard form. When you have an equation in standard form, it allows you to find intercepts quickly, and with those intercepts, you can draw the graph very easily. Let's explore. I'm going to plot some points along the y-axis. What do you notice that all of those points have in common? If you said that the x-coordinate is always 0, you're right. Anytime you have a point along the y-axis, the x-coordinate is always 0, and the y-coordinate tells us the location of the point. Let's take a look at some points along the x-axis. As I'm plotting them, do you notice anything that they all have in common? Yeah, if you said that the y-coordinate is always 0, you're right. Anytime you have a point along the x-axis, the y-coordinate is always 0, and the x-coordinate tells us the location of the point. Intercepts are the points at which the line crosses the x and the y-axis. If you can figure out the intercepts and plot them, you have 2 points for which you can connect the line and graph the equation. With the x and the y intercept, you will have a 0 in both of those points. Let's take a look at example number 1. We're going to find the x and the y intercepts, and then we're going to graph the equation with those intercepts. So in your notes, I want you to copy down for number 1 the equation 2x plus 6y equals 18. It is in standard form. We're going to first figure out the x-intercept. The x-intercept is along the x-axis. And we know that any point along the x-axis, the y-coordinate is always 0. The x-coordinate will tell us the location of the point along the x-axis. So we're going to take our equation, 2x plus 6y equals 18. And we're going to plug in 0 for y. I'm replacing the y with a 0. And I'm going to solve for x. What is the value of x when y is 0? I'm trying to figure out what point makes this equation true. Well, I know that 6 times 0 is just 0, and this just cancels out. So I end up with 2x equals 18, divide by 2, x equals 9. So when y is 0, x is 9. So my x-intercept is at the point 9, 0. So I'm just going to go along the x-axis and I'm going to graph the point 9, 0 right here. There it is. No need really to label it. All right, let's figure out what the y-intercept is. With the y-intercept, we know that this is going to be the location where the line crosses the y-axis. And any point along the y-axis, the x-coordinate is always 0. The y-coordinate tells us the location on the y-axis. So again, I'm going to start off by writing the equation. And now this time, I'm going to replace the x in the equation with a 0. And I'm going to solve the equation for y. When x is 0, what is y? What point is the solution in the equation? So 2 times 0 is just 0. I'm going to cross it off. That's 0. So I have 6y equals 18, and I divide by 6, and I get y equals 3. So when x is 0, y is 3. This point is the solution to the equation, 0, 3. So 0, 3 is right here. Again, really no need to label it on there. But what I've done is I've found the x and the y-intercept. And notice that in the x and the y-intercept, you have a 0 in both of those points, right? The x-intercept, the x-coordinate tells us the location, and in the y-intercept, the y-coordinate tells us the location. Now that I have these 2 points, I can go ahead and I can graph the line. Sometimes just using a straight edge is helpful. Mine's not going to be perfect. Maybe I'll use a pen just to kind of help me out here a little bit. I kind of want it to be pretty good. I did okay. I did okay. Definitely if I was on the computer, it'd be a little bit better. Okay, now I just want to show you something. I took the 2x plus 6y equals 18 and I just rewrote it by solving for the y. I converted it from standard form back to slope-intercept form like we learned in lesson 5.3. Now notice here how when I did that, I ended up with a y-intercept of positive 3, which I see here. My y-intercept is positive 3. And I end up with a slope of negative 1/3. Let's check it out. Let's see. Is there a slope of negative 1/3? Up 1, left 3. Up 1, left 3. Up 1, left 3. Well, what do you know? See, I took the equation, I converted it, and I get the exact same line when I graphed with standard form. Now, whichever one you think is easiest, that's your opinion. But I could graph in standard form by finding intercepts, or I could always convert it and I could graph the good old-fashioned way with slope-intercept form too. Just wanted to show you that these two are exactly the same. I get the same exact line. All right, so that was example 1. Let's look at number 2. In your notes, can you please write the equation x minus 2y equals negative 2? Of course, this equation is in standard form. We're going to find the x and the y intercepts, and then we're going to use them to graph the equation. This is how you graph in standard form. Okay, let's first find the x-intercept. Anytime you have a point along the x-axis, the y will be 0. The x, because this is the x-intercept, we're finding the x. What's the location of the x? So I'm going to take the equation, and I'm going to replace the y in the equation with 0. And I'm just going to simply solve for x. What is x when y is 0? Well, x minus 2 times 0. 2 times 0, that just kind of cancels out. And I end up with x equals negative 2. And there I have the x-intercept. So I'm going to plot that on my coordinate plane right here, negative 2. So I got negative 2, 0. There's my point. Now we're going to figure out what the y-intercept is. Okay, so y-intercept, this is going to be the point on the y-axis. So the x is going to be 0, and because I'm trying to find the y-intercept, I'm trying to find the location of y. So again, I'm going to copy the equation, and this time I'm plugging 0 for x. I want to solve for y. I want to figure out the y-intercept, so I'm solving for y. Okay, so this is just 0, so just think that cancels out. I have negative 2y equals negative 2. I divide by negative 2. I get y equals 1. Okay, so when x is 0, y is 1. There's my y-intercept. 0, 1, right here. So notice here with the intercepts, you have a 0 in both of them, right? Because any points along the x and the y-axis, there's a 0 in them, like we discovered that before. So I'm going to connect the points here. Not exactly perfect, but close enough, okay? It only takes 2 points to make a line, and when you're graphing with standard form, you find the intercepts and you graph the 2 intercepts. Now, just for the fun of it, I took the equation, because it's so fun, right? And I rewrote it, I solved it for y, I rewrote it, I converted it into slope-intercept form. I just want to compare. Here, I use the intercepts to graph in standard form. Here, I converted it. Now, let's compare our lines. It tells me that when I converted this, that the y-intercept should be positive 1. Do you see how we got that? The y-intercept is 1, and same thing with on my graph. Now the slope is supposed to be 1/2, is it? Up 1 over 2, up 1 over 2, up 1 over 2. Absolutely is. See how cool is that? Even though we're graphing using intercepts in standard form, it's the exact same line if it were written in slope-intercept. Pretty neat. All right, example number 3. Here we're asked to find the x and y intercepts of this equation right here. So go ahead and copy down this equation. It's written in standard form, and when it's in standard form, it's really, really easy to find the x and the y intercepts. I'm going to show you a different way that you can organize your work here. Sometimes students like to organize their work in a table, x, y. And we know that when we're finding intercepts, that those are points that there's a 0 in the x coordinate and the y coordinate. So sometimes kids just like to kind of organize their work in a table here. They put a 0 here and a 0 here. And then they start plugging in their 0 and they solve for either y or x. So you can always organize your work in a table if that's helpful. Okay, so here's our equation. 3x minus 5y equals negative 45. If we want to find our first point here, notice we're trying to find the y. That means this is the y-intercept. Okay, that's the location of the y. So we're going to plug in 0 for x. We're going to go right over here to this equation. We're going to plug in 0 for x, and we're going to figure out what is the value of y when x is 0. Okay, I know 3 times 0, that's just 0. It cancels out. So I'm just going to cross it off. And I have negative 5y equals negative 45. I'm just going to divide, just solving the equation for y, and I get 9. 45 divided by 5 is 9. So y is 9. So that would be the y-intercept. Okay, let's figure out the other one then. So I'm going to use a different color for this one. I'm going to write down the equation again. 3x minus 5y equals negative 45. Okay, this time I'm going to figure out the x-intercept. So I'm going to make y 0. So right over here, I'm just making y 0. Okay, so we have 5 times 0 here. That just cancels out and makes 0. 5 times 0. So really, I just have 3x equals negative 45. Divide by 3, and I get x equals negative 45 divided by 3 is 15. And there is my x coordinate, okay? Or my x-intercept. So here I have both of them. Now, you can either write your answer like this, or you could write your answer x-intercept. My x-intercept here is negative 15, and my y-intercept right here, where the location of y was at 9. Your answer could just be a number, or it could be a coordinate. It could be an ordered pair. It does not matter. This is just telling us where the line is going to cross the x and the y axis, okay? Let's look at number 3. Oh, sorry, we just did 3. We're going to look at number 4. On this one, I'm just asking you for the x-intercept. So here's the equation in standard form, and I want to know where is it going to cross the x-axis if you graphed it on a coordinate plane. So where's the x-intercept? Okay, so let's start off with determining what is that point going to look like. If I'm trying to find the x-intercept, that means I want to know the location on the x-axis. I want to figure out the x. Okay, and anything on the x-axis has a 0 as the y-coordinate. Okay, so I'm trying to find the location on the x-axis. So I'm going to plug in 0 for y. I want to solve for x if I'm trying to find the x-intercept. All right, so notice here I have 4 times 0. That's just going to scribble out and make 0. So I have 14x equals negative 7, and I'm just solving for x. Dividing by 14, I get x equals negative 7/14, which is negative 1/2. So negative 1/2. I said that wrong. Negative 1/2. So if I was to graph this line on a coordinate plane, it's going to touch the x-axis at the point negative half 0. So it's not always going to be a whole number. It could definitely be a fraction in some cases. All right, number 5. Then we're going to be getting to our next goal after this. Here we're asked to find the y-intercept of this equation right here in standard form. Okay, when an equation's written in standard form, it's very easy to find those intercepts. We're just going to plug in 0, right? So let's figure out what we're doing here. We want the y-intercept. That means we want the location of y. We want to solve for y. We want to figure out what is the y. The x-coordinate's always 0 of every point along the y-axis. So I'm going to replace the x with a 0, and I'm going to solve the equation for y because I'm looking for the y-intercept. So I'm solving for y. Well, 3 times 0 is just 0. Cross it off, and I have negative 8y equals 26. I'm going to divide by negative 8. So I'm just simply solving the equation, and I get 26 over negative 8. Okay, so that's negative. I know that I can divide 26 and 8 both by 2, which would give me 13/4. So I could have my answer as negative 13/4. I could also give this answer as a decimal, 3.25. So I could also say that it's at 0 and then negative 3.25. A decimal is equivalent, but either way, when I graph this equation on a coordinate plane, the line is going to cross the y-axis at negative 3.25 or negative 3 1/4. Okay, so again, they're not always going to be perfect whole numbers when you are finding x and y intercepts. All right, so now we're ready for our next goal. All right, so I want you guys to look at number 6 in your notes. Backing up here real quick. Our next goal here, the second goal, is I can graph horizontal and vertical lines. When you have a horizontal and a vertical line, there are those equations that have one variable. There's those special cases. And we've learned about these before. These equations are actually written in standard form. It's just that they're missing one of the variables because a 0 was attached to them. So they're just simplified. But equations that are in one variable are actually in standard form. Okay, so let's think about what we remember here. When we have the equation y equals 7, what do we know about that equation? Well, we know that it's a line, and we know that if we find positive 7 on the y-axis and make a point, we can draw a line through that point. When we have an equation that's y equals 7 and only has a y in the equation, it can only go through the y-axis. So if the line's only going to go through the y-axis, it's going to have to be horizontal, right? Can't ever touch the x-axis. Okay. And then when we have x equals negative 4, well, of course, if we go on the x-axis, we could plot a point here at negative 4. And because the equation only has an x in it, it can only go through the x-axis, which means the line is going to have to be vertical so that it only cuts through the x-axis. It can't ever touch the y because there's no y in the equation. Okay, so we've learned how to graph these special cases here where we have one variable in the equation. We either have a horizontal or a vertical line. Well, what I'm going to do here is show you a trick to remember how to graph these horizontal and vertical lines that are written in standard form. It is called HOI-VUX. I know that sounds pretty silly. It's kind of fun to say it. HOI-VUX. It might sound silly, but it's an acronym that will help you to remember what these lines look like because they can be easily confused. So let's just visit the HOI. Where's the HOI coming from? Okay, why is this helpful? Well, first of all, the H is representing horizontal. This is a horizontal line. The O looks like the number 0. It has a 0 slope, which is completely flat. Where do you think the Y comes from? Absolutely. The Y comes from the fact that this is a Y equal equation. So to use this as a helpful trick, when you think HOI-VUX, HOI has the Y in it, so it's a Y equals equation, which if I think of the word HOI, the O is a 0 slope and the H is a horizontal line. So students find this really helpful when they see the Y equals equation. They think, okay, that's HOI. They write out the word HOI and then they can think, oh, duh, HOI, horizontal line, easy. All right, let's go to VUX. VUX. All right, HOI-VUX. So VUX, I bet you can guess what the V stands for. Yeah, vertical. This is a vertical line. And the U, what do you think the U stands for? It has to do with a slope. It's undefined slope. And what do you think the X represents? An X equals equation. Absolutely. So anytime I see an X equal equation, I can think, okay, that's VUX. Spell out the word VUX, and then you'll see undefined and vertical, and you'll be able to easily draw that line. Okay, if this is helpful, pause the video and write this down in your notes. Practice saying it a few times, HOI-VUX, and you wouldn't believe how helpful this has been for some students to be able to keep the difference between the X equals and Y equals equation and to not get them mixed up, which one's horizontal and which one's vertical. Okay? Well, these were our goals. We learned how to find and graph the x and y intercepts from an equation in standard form, and we learned a trick to graph horizontal and vertical lines. Thank you so much for joining me. You guys have a great day and enjoy graphing equations in standard form by finding intercepts.